Welcome everyone in lecture number 21. In my previous lecture, I have told you about convolution theorem. So in this lecture, I'll discuss the problems on that theorem. My first problem is find Laplace inverse of p plus 1 divided by p square plus 2p plus 2 whole square. So first of all, we have to identify two functions fp and gp. So I can write this function as these two. I can split this into two parts. One is p plus 1 over p square plus 2p plus 2, and another one is 1 upon p square plus 2p plus 2, right? So I have told you कि आपको gp वो function लेना है जो simpler हो. Okay, so I'll choose this as gp and this as fp. So let me first take the Laplace inverse of these two to get the value of ft and gt. So Laplace inverse of p plus 1 over p square plus 2p plus 2 is obtained by using first shifting theorem. We make it as perfect square. So this is p plus 1 and this is p plus 1 whole square plus 1. Okay. So by first shifting theorem, it is equal to e raised power minus t into Laplace inverse of p over p square plus 1. So its Laplace inverse is obviously cos t. So this whole is our ft. Okay, this is our ft. Now we find gt. So we'll take the Laplace inverse of 1 upon p square plus 2p plus 1. We also make it as a perfect square to use first shifting theorem. P plus 1 whole square plus 1. So by using first shifting theorem, this is e raised power minus t into Laplace inverse of 1 upon p square plus 1. So this is e raised power minus t and its Laplace inverse is sine t. So this is gt. So once we obtained ft and gt, we are ready to apply convolution theorem on our question. So by using convolution theorem, Laplace inverse of fp into gp is integral 0 to t fu. What is fu? We replace t by u everywhere. So e raised power minus u cos u. E raised power minus u cos u. Then gt minus u is replace t by t minus u. We'll get e raised power t minus u sine t minus u du. Okay. So you can observe that this exponential power of e raised power minus u and here we have e raised power plus u, both will cancel each other. So that Laplace inverse of fp into gp is equal to integral 0 to t e raised power minus t will be left and cos u is left and sine t minus u is left. Du. That's so I'll take this e raised power minus u outside, minus t, sorry, and to make it as sine a cos b formula, that is equal to sine a plus b plus sine a minus b and divide it by 2 because we have to make it as 2 sine a cos b, so we'll multiply and divide by 2. So this is equal to e raised power minus t upon 2 0 to t sine t plus sine t minus 2u. Here I have missed du. So because this integration is with respect to u, so the sine t is constant. So its integration with respect to u is sine t into u, and this its integration is cos t minus 2u, and this 2 will come in the denominator, and that negative sign will adjust with this negative 2. Okay, so this is 0 to t with limit. So when you apply the limit here, uh, this is t sine t sine t plus, and this is half cos t minus 2t, which is cos t, and then you put 0, it is 0, and this is cos t by 2. So this cancel with this. We have Laplace inverse of fp into gp is given by half minus t into t sine t. This is the answer. Okay, let me take second example. Problem number 2 is find Laplace inverse of p upon p square plus a square whole square. Again we have to select fp and gp first of all. So we can divide this into two parts. One is p upon p square plus a square. Another is 1 upon p square plus a square. So this is taken as gp and this function is taken as fp. So I'll take Laplace inverse of fp first of all. So Laplace inverse of p upon p square plus a square. Its Laplace inverse is cos 80, and Laplace inverse of gp is sine 80. Sine 80 divided by a, because we have to make a present here, so we'll multiply and divide by a. Okay, so by convolution theorem, Laplace inverse of fp into gp will be integral 0 to t. This is gt and this is ft. So we'll have cos au, which is fu, and gt minus u is sine a t minus u. Take 1 upon a outside, du. This is gt minus u. So again we make it sine a cos b. So we'll 1 upon 2a here, sine of a plus b plus sine of a minus b. So Laplace inverse of Fp into Gp will be equal to sine of At plus sine of At minus 2Au. At minus 2Au. This is minus 2Au, okay? This is 1 upon 2A. Again, integration of this with respect to U is U sine At, and it is cos of At minus 2Au divided by 2A. 0 to T is the limit. T sine At plus cos of At minus 0, and this is cos of At by 2A. So just cancel with this 1 upon 2A into T sine of At, which is the answer. My third example is find Laplace inverse of P upon P square plus 2P whole square. So you can write this as, yeah, the trick of this question is you take P square common. No, here it is only P, I think. Let me correct the question. Let me correct the question. The question is find Laplace inverse of P upon P plus 2P whole square. So you can write this as P square. No, it's P square. We will take 1P as common, so that 1P will come outside as P square. Okay. So P plus 2P is left inside the bracket. The question was correct. Okay, this is the trick. So now this can be divided into two parts. One is 1 upon so this P will cancel with this P, and you can take one more P common, or simply when I take P common here I should not have P. That's make my confusion. Okay, actually. Okay, now this is correct. Now this is correct. Okay, when you take 1P as common, this is 1P is left here, and here only 2 is left. I have by mistake written as P here. Okay, I'm sorry for that. So this is 1 upon divided into two parts. One is 1 upon P plus 2 whole square. Another is 1 upon P. Okay, so this is selected as GP, and this is selected as FP. So Laplace inverse of Fp is by first shifting theorem e raised power minus 2t into Laplace inverse of 1 upon P square. So it's e raised power minus 2t and its Laplace inverse is t. So this is Ft. and take Laplace inverse of GP, which is equal to 1. So it's GT minus U. So Laplace inverse of FP into GP is equal to integral 0 to T Fu e raised power minus 2U into U, and GT minus U remains 1. So we have very simple expression in here. So we'll do the integration by parts. Fp into Gp is equal to that's integration by parts gives you the answer. When you apply the limits, the answer will be, I am writing the answer only, t raised power minus 2t whole divided by 2 minus e raised power minus 2t divided by 4 plus 1 upon 4. So you can check your answer. Problem number 4. Find Laplace inverse of 1 upon p minus 1 into square root of p. So here Fp here is taken as, can you guess? 1 upon root p. This is Fp. And Gp is taken as 1 upon p minus 1. So Laplace inverse of Fp Laplace inverse of Fp is Laplace inverse of 1 upon square root of p. That is equal to 1 upon square root of t into pi. And Laplace inverse of Gp is e raised power t. So this is Ft and this is Gt. So that's why we have selected this as Fp and this as Gp, because its Laplace inverse is complicated. So Laplace inverse of Fp into Gp will comes out to be 0 to t 1 upon square root of pi, and square root of t will become square root of u, fu, and gt minus u means t is replaced by t minus u du. This is fu and this is gt minus u. Now you can integrate this. Square root of pi and e raised power t can taken outside, and here we have e raised power minus u into u raised power minus half. So here to integrate this function, we suppose that u is equal to v square. So du is equal to 2v into dv, because that is going to become an error function. The limit will be 0 to square root of t, because when you put u is equal to t here, v will be square root of t. E raised power minus v square divided by v. Okay, du is replaced by 2v dv, and square root of u will be replaced by v. This v will cancel with this. Here we have 2 e raised power t divided by square root of pi, 0 to square root of t e raised power minus v square dv. If you look at this function, this is error function of square root of t, except this e raised power t. If you leave this, the rest of the expression is error function of square root of t. So this is equal to e raised power t into error function of square root of t. So this is the answer. You have to keep this integration in your mind. Whenever this type of expression comes, you can change it in error function by letting u is equal to v square. Okay. So I'll discuss more problems in my next lecture based on convolution theorem. Okay. Thank you very much for watching the video.